Hi, I'm Mason Vale from Boise State University. In this video, we'll look at common ways that we compare objects for equivalence and relative order as a foundation for discussing searching and sorting data structures. When we compare two objects to see if they're equal, we need to really understand what we mean by the term equal. Are we asking if two references point to the same object, or are we asking if two objects look alike? Do they have equivalent values? When we use the equals equals operator to compare two object references, we're comparing the values of those references. We're asking if they both refer to the same object in memory. Are these two objects aliases for one another? By contrast, if we use the equals method, what we're intending to do is compare the values of these two objects to see if they look alike. Are they equivalent objects? So the comparison that takes place in the equals method is looking at values within those objects to see if they're the same. Now it's important to note, if the objects you're comparing have not overridden the equals method, then equals has the same result as the equals equals operator. That method has to be overridden in order to perform its purpose, which is to compare objects for equivalence. Many classes implement the comparable interface, which has a single method, compare_to, which allows us to compare the relative ordering of two objects of the same type. Now, you only get one version of this compare_to method in an object that implements this interface, so it's very important that this method reflects the most common, most expected ordering for this type of object. For example, the compare_to method in the integer class is sorting objects according to their ascending order. You should think of it in terms of the natural order, the most obvious, most common order. If someone told you to put a collection of random integers in order, and that's all they told you, your default would be to put them in ascending order. So natural order should reflect the most common, most expected order. Now, the compare_to method returns a value, an integer value, to reflect the relative order of the two objects being compared. The sign of that number reflects which object comes first. So if the value returned is a negative number, then we assume that the object 1 in my example here, is the object that comes first. It's less than or smaller than the other object. If the number that's returned is a positive number, then we assume the second number is the one that's smaller or comes first. So object 1 comes first is a negative number. Object 2 coming first is a positive number. And if they are equivalent to one another, they should return a zero value. Now there's an expectation when you implement the comparable interface that the writer of this class should also be overriding the equals method so that the equals method would return true under exactly the same conditions that the compare_to method would return a 0. It's not something that can be enforced because all objects have an equals method inherited from the object class, but there is an expectation that if you implement the comparable interface in a class, you should also be overriding the equals method to be consistent with compare_to. As an example of how the comparable interface can be implemented in a class, we have this example contact class that represents an object that you might find, say, in a phone contact list. So the instance variables for this contact include a string for a person's last name and first name, and then a long integer for phone number. Now, because I need to fit this on a slide, I've left out things like the constructor, any accessor, and mutator methods. All that's shown here are methods that apply to the comparable interface. We can see in the header, the class header, that the contact class implements the comparable interface, and specifically, I intend to compare contacts to other contacts. So we're using the generic contact for the contact class to specify that contacts will only be compared to other contacts. By implementing the comparable interface, we have agreed to implement the compare_to method, expecting another contact as the input. The comparison that's made inside the compare to method is comparing last names and first names. Generally, if we're looking someone up in a contact list, we know the person's name, but we're trying to find their phone number. So we have partial information. As such, the compare to method only compares last name and first name. It doesn't include the phone number as part of its comparison. We will be satisfied if we find a name with a contact with the same last name and first name. So, as we would normally expect to alphabetize names in a contact list, we generally compare last names first and first names second. So the first comparison that's made in this compare to method is comparing the last name of this object to the last name of the other object that was passed in as an argument. And if that is a non-zero number, that's going to end up being the result that we return. If the last name of this contact compared to, using the strings compare to method, if the last name of this person comes before the last name of the other person, then we would expect to get a negative number stored in result. If the other person's last name comes before this person's last name, we would expect a positive number, and that's what we would return as a result. If they are the same last name, however, result would equal 0. So we would need then to compare first names to see relative order. And again, we compare first name compared to other first name using the string classes compare to method. If this person's first name comes first, we would return a negative number. If the other person's first name comes first, we would return a positive number. But if the first names match, last names match, and first names match, we will end up returning a 0, indicating that these two objects, these two contacts, are the same person. Same last name, same first name. Now, by implementing the comparable interface, remember there's that expectation that the equals method will be overridden. So I've included an equals method that also expects another contact. And the equals method is expected to return true under the same circumstances that the compare to method would return 0. So inside my equals method, I'm using the string classes equals method to compare last names, this person's last name to the other person's last name, and first name must be equal to the other person's first name. So both last name and first name must match for equals to return true, which is the same conditions that would return a 0 from the compare to method. Now, not every class implements the comparable interface and supports a natural ordering. We also have a circumstance that sometimes we want to sort by something other than the natural order. So we have the ability to define external classes that implement the comparator interface. The comparator interface includes a method called compare that works very similarly to the compare to method of the comparable interface. A negative value still indicates that the first object comes first, a positive value still indicates that the second object comes first, and a 0 is still expected when the two objects are equivalent to one another. Because this is an external class, there's no limit to the number of possible comparators that we could create for sorting objects of a certain kind. Those comparators are completely separate from the class that they sort. The benefit here is that I can have as many different sorting orders as I want, and also they don't require any modification to the sorted class in order to work. The only restriction is that anything that's being compared must be accessible by calling methods of the class. There need to be getter methods or accessor methods for any values that are going to be compared as part of the ordering. This example of a comparator takes in contact objects as its arguments and sorts them in the reverse order that we would have expected from the natural ordering. But this comparator doesn't assume that contacts have the comparable interface. We're going to repeat our comparisons using the strings compare to method. So the compare method takes in two contacts as arguments, and we're expecting two contacts because the comparator is defined to compare contacts. So it can't compare anything else, only contacts. Internally, we're using the same compare to method that we saw in our compare to method for the comparable interface. We're using the strings compare to method, but we're taking whatever value comes back and reversing it. We're using the negative symbol to reverse the sign of whatever value comes back. If that number was a 0, we still will compare the first names after we've compared last names. And again, we're reversing the sign on the value returned from the strings compare to method. So we get the reverse of the order we would have expected from the contact classes compare to method. So it's very simple. A comparator object implements the comparator interface, and you specify what kind of object you intend to compare. The compare method expects then two references of the type of object that you can compare, and inside you simply put in whatever code is necessary to determine the relative order based on your criteria. So it doesn't have to compare the same things that the natural order would have compared. You as the programmer get to decide how you compare something. If you want more comparator objects to compare in different ways, you can create as many different comparator classes as you want that all implement the comparator interface for the type of object you're comparing, and each one of those objects would differ by the code inside of its compare method. So these ways of comparing objects using the equals method for equivalence testing, the compare to method for relative ordering or for equivalence, looking for a 0 value, these are the ways that people do comparisons when we're trying to search for an object in a data structure or when we're trying to find relative positioning of objects for sorting processes.